Section 2.3, deductive reasoning. So, deductive reasoning, by definition, is the process of using facts, definitions, accepted properties, and laws of logic to form a logical argument. This is different from inductive reasoning, which we already talked about, that uses specific examples and patterns to form an educated guess on what happens next. That educated guess we called a conjecture. So they're different. So we're going to talk about these things again, and we're also going to talk about the law of syllogism. So what's the difference? Well, with inductive reasoning, what we talked about is if you look at some specific examples, like 3 consecutive integers, 2 plus 3 plus 4 equals 9, or -4 plus -3 plus -2 equals -9, or 10 plus 11 plus 12 equals 33. If we look at what's happening, we could say that the sum of any 3, we can make a conjecture, the sum of any 3 consecutive integers is the middle integer times 3. If we multiply by 3, it gives us the sum. If we multiply by 3, it gives us the sum. That is our conjecture. This is different from deductive reasoning, where we would use like actual math, facts, definitions, properties, things like that. So deductive reasoning, if we let like n equal any real number, then n plus 1 is the next number in order, so we call that the next consecutive integer, and n plus 2 would equal the third consecutive integer. So now, if we take a look at adding 3 consecutive integers, if we add n, and then we add n plus 1, the next consecutive integer, and then we add n plus 2, okay, so we could kind of put parentheses around here just to distinguish that this is the first number, this is the second number, this is the third consecutive integer. When we add all those together, what that equals is n plus n plus n, or 3n plus 3. And if we factor out a 3, that gives us 3 times n plus 1. So what we have here is we have 3 times our middle number, and that's using deductive reasoning, using accepted math properties and facts to come to that conclusion, the same conclusion we did with the conjecture we made on 3 consecutive integers adding up, or would be the sum of would be the middle integer here times 3. So, what is law of syllogism? Well, that's your logic chains. What that is multiple conditional statements that are related in a chain. And there's great examples of these, or used to be. They used to advertise DirecTV, and they would go through these series of different events that happened, and it would come to a very weird conclusion. And so we'll take a look at some of those next. So let's talk about law of detachment. The law of detachment is if the hypothesis of a true conditional statement is true, then the conclusion is also true. That's called the law of detachment. So this says use the law of detachment to make a valid conclusion to the true situation. So if we're using the law of detachment, then that is telling us that this hypothesis is going to be true. So if 2 segments have the same length, then they are congruent. And this is a true situation. So now you're being told, you know that BC is equal to XY. So your valid logical conclusion is that segment BC then has to be congruent to XY, segment XY. Or maybe this next example might be easier for you to kind of understand. If Nathan is enrolled at RHS, then he has a student ID number. So that's a true situation. So now it's telling you that Nathan is enrolled at RHS, so Nathan has a student ID number. So let's get into the logic chains. So in some situations, there is not enough to make proper conclusions based on only one conditional statement. Instead, what if we're provided with multiple conditional statements that are all related to each other? We could make a very different valid conclusion based on a different hypothesis. So, for example, if Joe takes geometry this year, then he will take algebra 2 next year. If Joe takes algebra 2 next year, then he will graduate. So what conclusion can we make? We can make that if Joe takes geometry this year, then he will graduate. So these are logic chains, and officially when we have multiple related conditional statements, like have the same, they're all in the same information and related to the same information, what we need to do is we need to make sure we put them in a logical order. And when that's completed, then we take the hypothesis of the first conditional statement and the conclusion of the final conditional statement, and we put them together to make a final conditional statement. So for example, write the final true conditional statement based on the logic chain. If Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A. So we have the first hypothesis right here, Rick takes chemistry this year, leads to this conclusion. That conclusion is now our next hypothesis, which leads to this conclusion. And so we take our original hypothesis here with our final conclusion and we put it together. So this would become, if Rick takes chemistry this year, then Rick will get an A in chemistry. So it's pretty simple when you have them in order, because the first hypothesis led to the conclusion. That conclusion has to become your next hypothesis, which leads to a different conclusion. And sometimes we have multiple statements. What gets difficult is when we have to put them in order. I'd like you to try to see if you can write the logical chain in order and then write the conclusion. If you put these statements in order, this is the first one, this is the second one, and this is the third one. So now we are going to take the original, the first hypothesis, if it is winter, and match it up with the final conclusion. So our conclusion, our final conclusion would be if it is winter, then birds fly south. Now, again, make sure you put them in order, and sometimes it does not always lead to a very a conclusion, I should say, that makes sense. A lot of times it leads to a conclusion that doesn't make any sense at all. So this next example, you have to put these in order. So go ahead if you can figure out which is the first statement. Here's your first statement. If you clean your room, then you will go to a movie. Now, the next statement has to be in order, has to begin with, you will go to a movie. So this is number 2. If you go to a movie, then you will spend all your money. So the third statement has to start with, if you spend all of your money. And then the fourth statement, if you spend all your money, then you cannot buy gas for the car. So now your fourth statement has to start with, if you cannot buy gas for the car, then you will be stranded. So now, once you have them in order, then you are going to take again the first hypothesis in your first statement. So if you clean your room, and you match it up with the final conclusion, then you cannot buy gas for the car. And that's kind of doesn't really make sense. If you clean your room, then you can't buy gas for the car? Doesn't make any sense at all. But that's what happens in logic chains. A lot of times they just don't really make sense. Now, you can also have logic chains that aren't just words. You can have mathematical logic chains. And again, you need to put these in order. And in order, if y equals 2, then 3x plus 4 equals 10. That would be your first one. This would be your first one. Sorry. There we go. And this would be your second one, because again, you have to make sure that this hypothesis right here led to this conclusion. Now that conclusion has to be your next hypothesis, which leads to this conclusion. So now what you could say is, if y cubed equals 8, then 3y plus 4 equals 10. So again, it's just understanding the process of what's going on. So this next piece is a little bit tricky. It says use inductive reasoning to make a conjecture about the sum of a number and itself, and then use deductive reasoning to show the conjecture is true. So inductive reasoning, remember, uses specific examples. So inductive is specific examples. So a number, the sum of a number in itself. So 2 plus 2 equals 4. -5 plus -5 equals -10. 10 plus 10 equals 20. So do you have a conjecture? Well, my conjecture would be the sum of a number and itself is twice the number. Because in those specific examples, if you take 2 and you multiply it by 2, you get 4. If you take -5 and you multiply it by 2, you get -10. If you take 10 and you multiply it by 2, you get 20. So that's my conjecture. It's based on some specific examples, and I'm sort of making a guess, an educated guess about what's going on. So now if I want to actually use deductive reasoning, that uses specific math properties, principles, etc. So now to use deductive reasoning, I would say let n equal any real number. Then n plus n equals 2n. And so since n plus n is 2n, 2n equals 2n, and so that is twice the number. So this is saying a number plus itself is equal to twice the number. So we proved it true with deductive reasoning. Again, these two pieces are kind of tricky. See if you can look at these and decide whether inductive or deductive is used. So if you look at the first example, all reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. So what are we using? Well, we're using facts about reptiles. This is a fact. Reptiles are cold-blooded. This is a fact. Parrots are not cold-blooded. So Sue's pet parrot is not cold-blooded, so it's not a reptile. So this is using deductive reasoning because it's using facts. The next one. Every time Tom has eaten a strawberry, he gets a rash. The next time he eats a strawberry, he will get a rash. Well, he's just noticing that he got a rash when he ate a strawberry. Could the strawberry have come from something else? Yes. So this is based on his observations of specific example and time when he ate a strawberry and got a rash. So this is inductive because it's using a specific example. Or time when he got the rash. And this last one is kind of interesting. It says, whenever it rains in the morning, afternoon baseball games get canceled. The baseball game this afternoon was not canceled, so it did not rain this morning. So I think the inclination is it's inductive because it's looking at specific examples of when it rained and they canceled. So it's looking at specific examples of rain and cancellations. But it could actually be deductive if it was based on policies that the park board has. So it can be tricky. Just do your best to try to understand what's going on. And here's the difference between law of detachment and law of syllogism. Again, these can be kind of tricky, but if the law of detachment is if the hypothesis of a true conditional statement is true, then the conclusion is also true. So it allows you to make a valid conclusion to an already true situation. Law of syllogism allows you to write a new conditional statement that follows from a set of true statements. So it's more true statements put together in a chain. And that is the end of